In this video, I take a look at the use of the iodoform test for particular types of alcohol. I'm using 2 molar sodium hydroxide solution, which I have in the left-hand boiling tube there, together with a 10% solution of iodine made up in potassium iodide solution. In the second test tube, I have ethanol. In the next test tube, I have propan-1-ol. And next to that, I have a position isomer of propan-1-ol, propan-2-ol, and then in the next test tube, butan-1-ol. And you'll see there that I also have a hot water bath. Let's consider what kinds of alcohols give a positive iodoform reaction. To give a positive iodoform reaction, we have to have a molecule that has a carbon attached to an OH and to both a methyl group and a hydrogen atom. The other group represented by or can be pretty much any other grouping. But the carbon attached to the functional group of the alcohol must have both a methyl group and a hydrogen atom attached. You'll see the requirement of the hydrogen is so that it can undergo oxidation in this first phase of the reaction. And the methyl group, the CH3 group there, its requirement will become clear in that that's the group that ends up forming iodoform, properly known as triiodomethane. Now, in the first step of this iodoform test, which uses iodine solution and sodium hydroxide, this is what happens. First of all, you'll be probably familiar with this reaction at the bottom here, the reaction between chlorine and a cold dilute solution of sodium hydroxide. It forms sodium chlorate 1, also known as sodium hypochlorite, which is an oxidizing agent and is the active ingredient in bleaches. Well, this is the reaction just above it here that is relevant in this instance. But you can see it's similar. Instead of chlorine, we have the halogen iodine. The chemical reaction then is very similar, and here we get sodium iodate 1. That's to say the oxidation number or state of the iodine is +1. Now, if that oxidation number can be reduced, and of course it can be reduced, for example, to 0 in the element or to -1 in the iodide ion, then it's capable of being reduced and therefore can behave as an oxidizing agent. And that's what goes on here in the first step of the iodoform reaction for alcohols. Iodine and sodium hydroxide then react as shown in the equation below there to form sodium iodate 1. And it oxidizes that alcohol as follows. You can see that it has removed the H, hence the requirement for the H attached to that carbon holding the functional group. It introduces then a double bond O. So it's effectively removed 2 H's, the H that was attached to the carbon directly and the H of the functional group OH. So we've converted the alcohol in the first step to a carbonyl. The R group there could be H, which would mean that we would have an aldehyde, but if it's a carbon-bearing group, then it would be a ketone that we get there. In the next step, the iodine then reacts with the methyl group. Hence, as I said, the requirement for the methyl group, forming Ci3. So the H's have been replaced by iodines. Then in the final step, brought about by hydroxide ions from the sodium hydroxide, we get that organic compound there splitting, and it will produce the sodium salt of an acid together with CHI3, triiodomethane, also known simply as iodoform, and you'll see that it is a pale yellow solid with an antiseptic smell. And there's the other product of that reaction. You can see it's the sodium salt of a carboxylic acid there. But the key thing is it produces iodoform, which is a pale yellow solid with an antiseptic smell. If we have an alcohol with that particular type of grouping, that's to say where we have ethane, known as iodoform. Pale yellow precipitate. I'm wafting the fumes towards my nose there, picking up the antiseptic smell. So why does propan-2-ol give a positive test? Let's look at the structure of propan-2-ol. There's it there. The OH is on the inside carbon. And does that inside carbon have attached to it both a H and a methyl group? Well, there's the H. And in fact, it has a methyl group either side. So you can see why it gave a positive iodoform reaction. Remember how the H there is removed in the oxidation reaction together with the H of the hydroxyl group. That happens during the oxidation stage. And then the H's of the methyl group are replaced with I's to give CI3. And then it decomposes with the hydroxide ions in the final step to create triiodomethane together with the sodium salt of a carboxylic acid. So here I've got the last one, butan-1-ol. Consider its structure and whether you expect this test to be positive or negative. So I've added about 1.5 times as much 10% iodine solution as alcohol, and I'm now adding 2 molar sodium hydroxide solution slowly with shaking. The butan-2-ol is a bit more viscous and takes a bit more shaking here. The colour is fading. Did need a bit more encouragement this to see whether it was going to turn into a colourless solution or instead produce a yellow precipitate. So keep watching here. The colour is fading. I did feel the need to use the hot water bath in this instance to encourage it. Still not completely clear whether it's going yellow or brown at this stage, but watch it as it sits now in the hot water bath. And I did add a good bit more sodium hydroxide to get a result. I needed either it to go colourless and clear, or I needed it to go yellow and cloudy. I wanted one or other result, so I kept adding sodium hydroxide and warming it in the water bath. In fact, I found I had to add even more sodium hydroxide to get one result or other. And at this stage I was convinced that it wasn't the yellow precipitate. Certainly no yellow precipitate there. And at the bottom you can see it has gone colourless and clear. Here's the structure of butan-1-ol. There's the carbon that's attached to the OH. You can see that it does have a H attached, but it doesn't have a methyl group. It has a propyl group instead, and that won't do. So that's why it was negative, exactly what one would have expected. So that's the ethanol. We had a positive test with that, and we had a positive test with a propan-2-ol there. We had a negative test with a propan-1-ol, and we had a negative test with the butan-1-ol.